Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. In this tutorial, we will explore asynchronous programming in a Spring Boot application. Asynchronous programming allows your application to handle multiple tasks concurrently, which can improve the performance and responsiveness of your application, especially when dealing with I/O bound operations. What is asynchronous programming? Asynchronous programming enables the execution of tasks without blocking the main thread. In a web application, this means that while one request is being processed, the server can handle other requests simultaneously. In Spring Boot, we can achieve this using async annotation and completablefuture. Prerequisites. Basic understanding of Java and Spring Boot. JDK 11 or later. Maven or Gradle for dependency management. An IDE, like IntelliJ IDEA or Eclipse. Step 1, create a Spring Boot application. You can create a new Spring Boot application using Spring Initializer, https://start.spring.io. Select the following dependencies. Spring Web. Spring Boot Dev Tools, optional for development. Spring Boot Starter AOP, for aspect-oriented programming. Step 2, configure asynchronous support. In your main application class, enable asynchronous support by adding the @enable async annotation. Step 3, create an asynchronous service. Next, create a service that will handle the asynchronous tasks. We will simulate a long-running task using thread.sleep. Step 4, create a controller. Next, we will create a controller that will expose an endpoint to trigger the asynchronous task. Step 5, run the application. Now, you can run your Spring Boot application. If you are using an IDE, run the async demo application class. Step 6, test the asynchronous endpoint. You can test the asynchronous endpoint using a tool like Postman or curl. Make a GET request to http://localhost 8080/async task. You will notice that the response is returned after 5 seconds, but during that time, you can make additional requests to the server, and they will be processed without waiting for the previous task to complete. Step 7, handle exceptions. You can also handle exceptions in asynchronous methods. Here's how you can modify the service to throw an exception. Step 8, testing exception handling. You can create another endpoint in the controller to test the exception. Conclusion. In this tutorial, we explored how to implement asynchronous programming in a Spring Boot application using the async annotation and completablefuture. Asynchronous programming can greatly enhance the performance of applications, especially when dealing with I/O bound tasks. You can further explore advanced topics such as configuring thread pools for asynchronous tasks, using async with Spring's task executor, handling timeouts and cancellation of asynchronous tasks. This should give you a good starting point for using asynchronous programming in your Spring Boot applications.